Good morning, everyone. It's great to be here back in Canada. I was a little disappointed yesterday when I saw pictures of snow and I got up here and it was all gone. I haven't seen snow in a little while, so I was looking forward to that. Also very excited to start off today's track with security. All right, so the other sessions for this track will be, say, digital transformation, culture of innovation, right? But you can't really get there until you got security nailed down, right? So your security teams, your CISO feels comfortable with moving to the cloud. So very happy to be here today and kick off the management track with security. My name is Michael South. I lead the security and compliance business development across the Americas. I've only been with Amazon for a little over a year. Prior to AWS, I was in the US Navy for 25 years, where I had a variety of positions, from running the networks in Europe to being the Chief Information Officer, CIO for Japan. When I left the Navy, I was the Deputy Chief Information Security Officer, or CISO, for the city of Washington, D.C., and that was where I started with my cloud journey. I'm going to talk a little bit about some of the challenges that I face and what a lot of our customers face with an on-prem environment. And then how those challenges actually are benefits in the cloud, and how security is starting to become a driving force behind moving to the cloud. So once I kind of set up that particular stage for you within AWS, we have a speaker from Palo Alto that's going to come in and talk about how Palo Alto integrates with AWS to really continue your security operations in the cloud. So with that, so one of the challenges that I had in managing on-prem data centers was visibility. You would think that you physically own your data centers, you physically own the servers, that you can maintain 100% visibility. But in today's virtualized environment and connected to the internet, that physical control, that physical visibility does not equal logical visibility. And so I can't tell you how many times we lost sight of a server. Maybe it got segmented off to some network. The endpoint protection stopped reporting up. Next thing I know, I got a server that's got an old OS on it, hasn't been patched, who knows what's wrong with it. And we're always trying to scramble to recover and figure out what happened and not let it happen again. The other challenge we had was resiliency. So in the US Navy, we had very mission critical applications that had to be able to survive any type of environment. For the city of Washington, D.C., we had very critical city services that had to stay up and operational for the citizens through a natural disaster, a man-made disaster. And so it was very challenging in a couple of data centers, or one data center, to get that resiliency up to really support those mission-critical applications. Defense in depth was also another challenge. All right, we've been talking about defense in depth for decades, but that's not really the reality that we see quite often. And then last was automation, a lack of automation. Right? It's very difficult to automate when you have a variety of different technologies across all platforms. So we have people who spend a lot of time on manual tasks to get security done because it's very difficult to automate. As I went through my journey in the cloud, not really having done cloud in the Navy, but starting to support the cloud in the city of Washington, D.C., trying to figure out how we were going to implement governance, how we were going to manage risk, how we were going to meet all our compliance requirements, how we were going to do security operations in the cloud. I found that all of these challenges in an on-prem environment actually became benefits of the cloud. I'll go over a couple of them here today. So starting with visibility, right? Visibility was really the key. Visibility goes into the CIS top 20 controls number 1 and 2, right? Inventory of your physical devices, inventory of your software and logical assets. Within AWS, we have a couple services that are very similar to what you might see in an on-prem environment. We have CloudTrail, which is our API logging service. Logs all the actions going on inside of your environment, who took the action when, what service, what was the action taken. The difference there, though, is that you might have logging services or event logs across all your multiple systems, but this is one logging service that spans your entire infrastructure, right? So now you get a much more holistic view of everything going on. It's all nicely, tightly integrated. We have the Amazon VPC flow logs, which is your network traffic going in and outside of your virtual private cloud, or VPC. It's basically your security boundary around your application. We have Amazon CloudWatch, which is very much kind of like a SIEM, but without necessarily all the correlation. But it tracks all your events, it alerts on events within AWS. And we have your web application firewall logs. All right, so those are very similar to what you're used to on-prem, right? A little bit different. I think CloudTrail provides a little bit more of a holistic service, but then that starts kind of like what you're used to on-prem. So this provides a little bit of a mapping or correlation of what you're used to on-prem to the cloud. Inspector is also very similar in the fact that it's a vulnerability assessment tool. So you might be using other tools similar to that now. What changes, though, in visibility is now when you have this homogeneous environment with all this information across all your services, you're able to add more context to what you're seeing. So when you look at AWS Trusted Advisor, Trusted Advisor specifically looks for security best practices that you may not be following. It gives you recommendations. Hey, you are not using multi-factor authentication on your root account, or you have your S3, your simple storage service, which is an object storage service from Amazon Web Services, that's open to the public internet. You have Amazon Macie, which is kind of similar to a data loss prevention service, but instead of sitting at the perimeter where most of them sit, looking for data that's leaving your network, it gives you a great sense of the sensitive data you have within your network. All right? Personal information, credit card numbers, encryption keys, and so forth. Okay? And then you have AWS Artifact, which is actually it's not really a true service in the sense that it does a lot of interaction with your other services or your data, but it's where you'd be able to obtain all of the AWS audit reports that we've gone through. So you can validate that what we say we're actually doing, because we're being audited all the time, and we provide those reports to you. And in the center, I have Amazon GuardDuty, which is an intelligent threat detection service. I'm going to go into a little bit more of that later. So all of these specifically to security, and then the other inherent visibility capabilities of all of our services provide you significantly more visibility than what you oftentimes see in an on-prem environment. So this kind of sets the stage, right? Because you can't really move forward with security or automation until you get the visibility. So I'm going to go into resiliency. A little bit about our architecture. We have 18 regions, 55 availability zones, and 121 edge locations. Now, while all CSPs use similar terminology such as regions, we don't all have the same definitions, right? So this is where some of the challenges can be from a customer that's trying to evaluate CSPs, trying to figure out, well, where am I going to get the resiliency, right? Is the infrastructure really going to be there when I need it? On your right is all the regions we currently have. The numbers on parentheses and the numbers in the circles on the map are the number of availability zones in each region. The map does not depict the edge locations. So what is a region for AWS? A region is a metropolitan area, isolated environment for your workloads, okay? Whatever data you put into an AWS region stays in that region. We do not copy, backup, move your data from the region you selected to any other region, okay? And we're able to meet our service level agreements with you for uptime, availability, and durability because of the architecture we have within our regions, okay? This can be a challenge for some CSPs where one region may equal one data center, right? So if that data center is lost, your service is out. Not only that, but they oftentimes may have to back up your data to another region, which you may not be familiar with or have any visibility into, in order to maintain that SLA with you. So that's an important aspect. So what is a region, though, for AWS? And a region in AWS is comprised of 2 or more availability zones. An availability zone is a fault isolation zone. Okay, it's a logical concept that allows us, where we manage our services, or if there's a service outage, or if you're going to do maintenance on your high available applications, that you can scope that and limit the effects of that to a particular subset of services, okay? So what that means is, if, for example, we were to lose a data center for some reason, it wouldn't take down all the services in a particular region. If you have your workload architected for high availability across multiple availability zones, the loss of a data center for us would not impact your application, okay? And then, of course, our data centers are built like very many others, right? Low-risk floodplains, multiple ISPs coming in from multiple providers, multiple power coming in from multiple providers, and we specifically build our regions in areas of low risk. Okay. So what does that mean for the customer? This is going to be a little bit of an eyesore, but I'll walk you through a little bit. So we have what would be maybe your traditional 3-tier web application in an on-prem environment. You may have more perimeter protections, but we're just going to save a firewall for now. You have a load balancer, which is typically one device, a couple web servers, an app server, and a database server. You're spending a lot of money for these servers to maintain whatever the workload it may be. So in this example, we're going to use, say, you're a university and you have a course registration application. Okay, most of the year, it's only being used a small percentage of the time because students really aren't registering for classes all the time. But 2 or 3 times a year, all the students will hit that server, hit that application, and start registering for class. Okay, so you have to buy these very expensive servers in order to be able to meet that high workload environment, which is only 2 or 3 times a year. So as you move to AWS and you want to get that high availability, this is what it's going to look like. There we go. Now, that can be a little daunting at first. And you can also think, well, that means I'm basically, I'm adding all these extra servers and capabilities. It's going to cost significantly more, right? Which is not necessarily the case, and I'll walk through that a little bit. So in this case, you're going to pick your region. Right, so I think for most in here, it'll be the Canada-Montreal region. You're going to create your VPC. This is your virtual private cloud. This is the security boundary around your application. You're going to select 2 or more availability zones. All right? Now think of an availability zone of 1 data center. The reality, though, is that AZs typically have more than 1 data center. There's always a minimum of 1, but there's typically more. Okay? So once you have that, you'll put in your perimeter protections. In this case, we have a Palo Alto firewall. Then an elastic load balancer. That's that first round icon in the center. What changes here that is your traditional single load balancer, which is a device, if that fails, even though it's a load balancer, you're still going to lose your entire application. The AWS ELBs, elastic load balancers, are sitting on thousands of servers. Right? So if we lose 1 device, we lose a couple, we lose a few, it's not going to affect. You're going to be able to maintain that load balancing across the web servers. Right? Now you're going to have 2 web servers like before, but now they're in 2 separate data centers. Okay? So you get some high availability there. You're also going to create an auto-scale group. This is one of the most dynamic changes between an on-prem environment and a hyperscale cloud provider. Is that now those 2 web servers, instead of being the monolithic, very large servers that you have on-prem, they can be very small servers that you're not going to be paying very much for. Just enough for your course admins to be able to maintain the application and the courses, update them as they change. What will happen, though, is when you open the registration season for courses, the autoscale group will see the increased demand on those web servers and automatically spin up additional web servers to take the load. Right? So now you're only going to be paying for those servers when they're up and running. When the registration season is done, then those servers will spin back down, and you're back to just what you need to maintain your application throughout the year. Okay? Now we go to the next tier, and now there's another elastic load balancer. So now you're getting load balancing between the tiers of your application, which in some cases you might have that on-prem, but then it gets very expensive in an on-prem environment to keep adding load balancers in between all your tiers of your applications, especially for each application. And then you'll go down to your database servers. Now in this case, the database servers are if you're managing your own. If you're running your own instance, maintaining your own operating system, and the database application in the database. In AWS, you can shift that from an EC2 instance to an AWS managed database service. All right, now you don't have to worry about the operating system, patching it, the database application, or patching it. You only need to worry about creating and maintaining your database and your data in it. Okay? So that can significantly offload a lot of the work for you that you need to do. In my experience, one of the greatest challenges was patching database servers or those applications. All right, so now this kind of alleviates a lot of that for you. So this is how you start getting resiliency within AWS. Defense in depth. Again, I said we've been talking about this for decades. So my entire time in the Navy, and we've been talking about it. The reality is this. You get a nice hard outer shell and a nice soft gooey middle. Right? Even all the protections we typically see, they're still just layers within the perimeter. Okay? So within AWS, my experience found, and what we're seeing a lot of our customers, they're starting to see the advantage of where they can obtain true defense in depth through their applications. And this is where we're going to start. The perimeter. Okay. Not much is going to be too new for you here. Right? So you're going to have your VPC, your security boundary, and you're going to have your access control lists. This is essentially your stateless firewall around your application. By default, a VPC has no connection to the internet for your application. You have to create an internet gateway. Okay? We have AWS Shield, which is DDoS protection. Everybody by default gets DDoS protection in AWS. Right? You're going to have to pay for that in an on-prem environment. We do have AWS Shield Advanced for those who need a little bit more protection, where you have timed SLAs with a human response team, a little bit better mitigating actions and monitoring. But by default, everybody gets DDoS protection. We have our own web application firewall. It's a good firewall. Protects against cross-site scripting, SQL injections. But then, like a lot of our products, they're what we call minimally viable products, right? MVPs. We start with the basics, and we'll expand as customers need more. But we have phenomenal partners. We have one of the largest ecosystems of security partners in the industry, Palo Alto being one of them. And so if our WAF doesn't quite necessarily meet your needs, you can bring in a partner solution, such as Palo Alto, to help with that, with whatever the additional features you may need. And I have Amazon GuardDuty again there. Again, I'm going to talk about that in a little bit. So this is your perimeter. So really, other than the free DDoS protection, this probably isn't anything different than what you have right now. Well, very similar, right? But this is where we start changing. In most of the data centers that I've seen, have been in, or managed, once you're in, you're trusted, right? So even though application processes will force data through the right applications and servers, once a server inside a data center is compromised, oftentimes the network connectivity is there so they can go and reach other servers within the data center, even in applications that have no need to talk to that particular application. Right? So once you move your applications into AWS and you have this VPC, the security boundary, you now have a security boundary around every application. Again, it's very expensive. Even if you were going to buy a less expensive stateless firewall, it's very expensive to do that on-prem environment between all your applications. Right? Typically, we see VLANs, which is really more about network traffic than security, although it has security benefits. But now you're starting to get that security boundary between applications. We have the perimeter and between applications. But this is really where it really comes in. Oh, actually, I need to add this. Now, you can add an internet gateway between the VPCs so that you can have at the application layer, they can communicate with each other if your applications need to communicate. You can create a VPC or VPN connection, or you can do VPN peering from the networking perspective. So you can always allow communications between your workloads if you need to, but you still have that security boundary around each one. But this is where it really gets good for security or defense in depth. You're still able to use the third-party tools on your instances for endpoint protection, antivirus, whatever you've got going on. We still have Amazon Inspector, or you can use third-party tools such as Nessus or Nexpose to scan your instances. We have Amazon CloudWatch, which I talked about, for event monitoring, and CloudTrail for logging. But the security groups, when you create a security group around each of these tiers, a security group is equivalent of a stateful firewall, okay? So now you're able to get security around each tier of your application. In many applications, again, even though the application process may require traffic a certain way, if somebody was to compromise the web server, oftentimes the network connectivity allows an attacker to move from the web server straight to the database server, right? That should never happen. With the security groups, with the stateful firewall, you can now limit the communications. So anything coming from a web server can only communicate to the application server. Application server can only go down to the database server and back up. Okay? So now you're able to get this true defense in depth at the perimeter, between applications, and within tiers of an application. And lastly, on the security groups, by default, as your web servers or whatever servers you have spin up to meet demand, any of the servers you have at that same tier level within a security group, by default, cannot communicate with each other. Again, if there is no reason for one web server to talk to another web server, if that's going on, it's because somebody's compromised the one and they're loudly moving over to the other, right? They're just seeing this wherever they can go. So now, perimeter, between applications, between tiers, and even in the same tier, you're now able to achieve a true defense in depth in the cloud without having to spend a ton of money on not only firewalls on the outside, but firewalls all throughout the inside, okay? And how you're going to be able to manage this without a whole army of engineers is through automation. At AWS, our philosophy is get the humans away from the data. Okay? Our CISO, Steve Schmidt, put a requirement out to reduce human access to data by 80% year over year. Okay? He knew if he did 10%, it would be a simple matter of a service team saying, oh, hey, Bob, I'm just taking away your credentials, right? You can develop, but you just can't deploy. You can't touch where the data's at. So he drove an 80% requirement as a catalyst for true change to really challenge how we do business and continually think about automation. Automation helps prevent human error, helps prevent a malicious insider attack. It helps prevent mistakes, right? So moving to Amazon GuardDuty, this is what starts some of the automation process for us as a service for our customers. So GuardDuty, again, is a threat intelligent detection service. You can enable it across multiple accounts. It analyzes your CloudTrail events, your VPC flow logs, and your DNS logs. It brings in third-party threat intelligence from Proofpoint and CrowdStrike, and threat intelligence that we create managing our global infrastructure. And it adds context to what it sees. And it gives you, it's basically intelligent alerts, right? So right now, if you were to look at all of the activity going against a web server you may have, right? As soon as you put a web server on the internet, it's being scanned. It might be being scanned by Google to add to the search engine. It might be scanned by just somebody who's just interested of what's going on the internet, a security analyst. Or it might be scanned by cyber criminals, right? You just never know. So this is where the threat intelligence will come in and help provide some context, and I'll go over that in just a minute. So Amazon GuardDuty, everything in white is based of a signature-based or stateless findings or threats that it can detect. Everything in blue is behavioral or stateful findings or threats that it can detect. We had a commercial customer who, a couple folks in their IT department decided to install Bitcoin mining software on their Exchange servers. They're running Microsoft Exchange servers, their production servers in AWS. If anybody's ran those typically run at high utilization. So they thought they could hide the Bitcoin mining activity in a server that's always highly utilized. As soon as they turned on GuardDuty, GuardDuty detected that behavior, alerted them to where the servers were that had that software install it, and because of the logs, they knew exactly who did it when they did it. So they were able to mitigate the risk technically where it was at, and then deal with the internal organizational challenges they had from the logs. So using Amazon GuardDuty, for example, when I was talking about that scanning, if your web app server is being scanned by a known cyber criminal's IP address, right? So as the threat intel comes in and it says your web server is being scanned, it'll give you context that this is a known malicious IP. This IP address has done bad things on the internet elsewhere. It's coming from this country. You may be concerned about, cybercrime or specifically from what country it's coming from. This is the ISP. It gives you what servers it's attacking, what type of scan, okay? So as you're able to get that context information, you're now able to better navigate all the alerts and focus your attention on things that are maybe a little bit higher risk than other similar scans, but maybe not coming from a known malicious. And so this is where we're able to automate. So if we take that cyber criminal IP address that's known bad, that's scanning your network, that'll generate a CloudWatch event. From that CloudWatch event, you can have a Lambda function. Now, Lambda is our serverless function service. So think of it as several functions, commands, scripts, ready to go, waiting for something to trigger them. All right, it's not a full application. You don't have to manage the servers for these. So now you have a Lambda function ready to go. As soon as a CloudWatch event comes up with that malicious IP address that's doing a particular type of scan on your web server, that Lambda function can take that IP address and insert it into your web application firewall. Now, that scan will automatically stop on that server, won't be able to continue to scan. Even if they were able to find an exploit or a vulnerability in the first few seconds that it was allowed to scan, it won't be able to exploit that vulnerability. And now it's protecting your entire fleet, right? It's not just protecting that one server, it's protecting that entire fleet. You can also add human stop gates if you need to, so that if you do need a human to make a decision on something, you can have all the automation, gather all the information, and propose a couple options to a human. So if you have a SOC analyst, a security operations analyst or center analyst, they can be presented, hey, this is what we found. Click here to insert in WAF, click here to add to ACLs, click here to ignore. So you can add that human stop gate if you really need to. But you're not just limited to AWS services. You can integrate that reporting into other partner solutions, email messages, SMS texts, whatever you need to do to mitigate that threat and provide the proper reporting. You can put that into any GRC tool as well. So what we're seeing is, on the far left, we see the web applications and websites. This was traditionally what most of our customers started moving to the cloud with first, right? Low risk, allowed them an opportunity to learn and grow before they started doing more sensitive workloads. This was also a time when we saw that security teams were not necessarily brought in from the beginning, right? And what happened is, at some point in time, there became a collision. So as the CIO, the business unit team, the app developers got past the web applications and started to get to the point where, okay, we want to do more mission critical applications, that's when they kind of ran into security and had some challenges, right? What we're seeing now, and what we highly advise our customers today starting out, is your CISO, Director for Cybersecurity, whoever is in charge of security and his team and his or her team should be there from day one. Okay, and from the initial discussions. So what we're seeing because of that is security operations is now one of the first workloads we're starting to see, and what we're highly recommending, right? Once the security team gets comfortable with the cloud, right, which is, again, why we have security as our first talk for today, right? Once the security gets comfortable with the cloud and with AWS, and they start figuring out how they're going to do incident response, how they're going to implement governance, and how they're going to be able to manage that and incorporate all of that into their in-house processes, then it really opens up the door for everything else. All right? And I know sometimes this can be a challenge culturally or politically within an organization, but I'll tell you, you're going to get to that discussion at some point, and it's much better to have it from day one than later on down the road. I think this is a very powerful statement from NASA. All right? NASA's got some of the most intelligent people from all around the world, literal rocket scientists. And they still think that we can do security better than what they are able to achieve on-prem. Right? Nothing against them at all. They're fantastic. I'm sure they could do quite a bit. But at the scale in which AWS is able to provide, and the ability for you to automate your processes. When I was in DC, the ability to automate was really key for us, right? So now, instead of having a lot of people working on very manual tasks, so if you think of a SOC Tier 1 analyst, somebody who's generally young, inexperienced, straight out of school, but highly intelligent, highly motivated, then you can automate a lot of those processes that they do, and they can focus on things that they're going to learn and grow a little bit more. And so with that, I'm going to like to bring up the co-presenter to talk more specifically about Palo Alto and how you integrate with AWS.
Thank you. Hi, good morning, everyone. My name is Patrick Hamel. I'm the system engineer for Palo Alto Networks. Oh, the clicker is here. That's good. No one told me how to use the clicker, so there we go. There's a next button there. So so I cover federal government for Ottawa from Palo Alto Networks. So today we'll talk about how to secure and automate AWS deployments in cloud. So let's start about, I want to talk about secure operating platform. So this is a concept that Palo Alto created a couple months ago. And basically, we created an operating platform because we know we can't take care of everything in the cloud or how to secure all the different use cases. You can see at the bottom, network, endpoint, and cloud. So we can provide sensors in all these locations, right? So we have network sensors for like network and firewall that collects a lot of data, a lot of threat intel data. We have an endpoint called Traps that can be installed on the endpoints in your private data center or in the cloud that can collect data as well, log data, threat intel data, and then we obviously are able to be deployed in cloud. It's provide a lot of data as well. So we collect a lot of that data. What we do is that we provide an application framework for third-party innovation and customers to be able to innovate and create their own applications on top of this data. In some cases, we know that we can't take care of every single use cases. So we allow our third party, sometimes or even our competition, to create those applications, and then customers as well to create those applications, so leverage all the data that we can collect in the cloud. And obviously, we have our own applications that uses this collected data, this aggregate data, and we'll get into that a bit later. So the slide that says that we are the best. So the jokes aside, but basically this is just a slide to show that, yeah, we're a global company. We deal with 85 of the Fortune 100 companies right out there. So we just surpassed our competitor, Cisco, to be #1 enterprise security vendor in the industry. So according to market share from Gartner, we sell basically more enterprise security than anyone else out there. And we have 54,000 plus customers. One really important thing about those 54,000 customers is that out of those 54,000 customers, we have 32,000 customers sending files to Wildfire, which is a threat intelligence cloud. All right, all kinds of files that we use to create automated policy enforcement on all our sensors, or endpoint in the cloud or on-prem, or firewalls in the cloud or on-prem. Right. So for us, it's really, really important to have all this customer base. Out of those 54,000 customers, when our customers purchase an endpoint from Palo Alto Networks, an enforcement point like a firewall, automatically we allow them to send PE files to the cloud for free, so we can start collecting all that data automatically. And then if they buy like a Wildfire license, we can send up to 30-some file types to the cloud. So we have 32,000 customers like that sending a lot of files to the cloud. So we have petabyte and petabyte of information. According to Forrester, we have the biggest threat intelligence cloud in the industry. Right? We collect the most data, and we apply machine learning algorithm to this data to be able to create signatures, and we'll get into that. So consistent prevention everywhere. So we like to, we think that we can provide our customers a consistent approach to prevention, not just in the cloud, not just on-prem, but also in the cloud. Right? A lot of our customers that we have, like they have us on-prem for their typical data center prevention, or for private cloud perimeter. They're going to the cloud, and they want that consistent prevention everywhere, right? They're able to prevent what they're seeing on-prem in the cloud as well, able to manage these environments the same way. So we can definitely provide that consistent prevention approach everywhere through our Panorama central management platform. We can manage our cloud deployment and our on-prem deployment. So let's quickly talk about shared responsibility. I'm sure you guys seen this slide about 20 times in the last month, so I'm not going to dive too much into that. But basically, AWS and the customer has different responsibility, right? AWS is security of the platform, mostly securing the infrastructure, and the customer are responsible for security in the cloud. And there's a lot of opportunities to insert ourselves in securing these workloads. Obviously, we have to, so customer content has to be secured. The operating systems, access, those are these different sort of services, encryption, key management, where we can use API-based security for that. So we'll get into that a bit later. So today we'll mostly concentrate on IaaS and PaaS services. We can also address SaaS and private as well. I'll be at the booth all day, so if you guys have any questions on how we can address private cloud and SaaS-based approach, you can come and ask me any questions you want. So securing the cloud is ours. Obviously, we all know that. A couple of key points here. Fragmented security, right? So customers that are deployed, they have private data centers, and now they're getting to the cloud, and they're starting to buy all these different tools to secure those cloud deployments. Now they're, obviously the cloud has different type of use cases, so they end up like buying all these different tools to secure the cloud. And we like to think that we can provide an approach that is consistent in the cloud and in on-prem, so that you don't end up with a fragmented security where operationally it becomes really hard to manage cloud and on-prem because they're not in sync. Manual security. Manual security is a problem, obviously, for like where we're used to in a data center, typical data center, to provide a manual security. Like we have flows in a data center that we protect, right? And usually those are based on IP addresses and ports, right? Obviously in the cloud, this is really difficult and impossible to use this type of approach in a cloud deployment, right? So in the cloud, things are very dynamic. You can spin up and spin down workloads really quickly. And we need to be able to address that to be able to secure these workloads as they get spin up and spin down, right? So we do things at Palo Alto Networks like, we leverage the APIs at AWS Expose to be able to scan the content of a VPC as an example, and then retrieve all these attributes that are exposed through this API. And using these attributes, we can build what we call a tag to IP database in our firewall, so we can map these attributes to tag on our firewall, and we can use what we call a dynamic access group, so that we can pre-populate these policies in the firewall, and depending on the attributes that we collect from AWS from these APIs, we can create dynamic policies, right? That's really, really important when you move to cloud to have an environment that's fully dynamic, right? And we can do that today. And obviously, human error, like my colleague said before, it's really easy to make mistakes in the cloud because automation is good, but automation can also be bad, right? You can spin up an instance really quickly, and it only takes seconds for it to start being scanned and probed on the internet, right? So someone will look into, like, is RPC open? Is the telnet open? SSH open on that instance? People will start scanning these IPs. There's scripts, there's bots out there that the only thing they do is scan these environments, right? So you obviously need automation to secure these environments, right? And we can provide that as well, right? Through, obviously, CloudFormation templates or Ansible or Terraform templates. We both automate these deployments so they're deployed according to best practices. So trivia question. According to Gartner, through 2020, of cloud security failure will be the fault of customer fault. I don't know, 95%. I'm not sure how accurate that is, but I'm sure it's pretty close because, again, because things can be very automated in the cloud, we have to make sure that everything is secured and according to best practices. So we'll get into how we can fully secure cloud environments automatically. So let's talk about IaaS and PaaS. So our vision to cloud security is really 3 pillars. The first is our inline security. Our inline security is our next generation firewall. This is what most people know Palo Alto Networks for, is our next generation firewall, right? So our next generation firewall protects, perimeter entry, outbound and inbound, between application tiers. And our next generation firewall is application aware, user aware, and content aware, right? What the business actually cares about, right? Business doesn't care about ports and protocol, it cares about the applications, right? Cares about the users using this application and what type of content is being transferred on the application, right? So we can protect based on IP, app ID, application identification, user ID, and content ID. So as an example, we can be between application tiers. We can be looking at MySQL connection back from an application to a database. We can enable only MySQL server or MySQL application or the actual signature for that traffic to go through, not just a port for MySQL, but the actual traffic, because we have a signature that looks for the application, what that application looks like on the wire, and only allow that application to talk over to the database or look for MySQL. Now, next generation firewall also includes IPS functionality, so full IPS for prevention, and also includes full antivirus scanning as well. That's stream-based. And all that prevention that's built into an next generation firewall comes from a threat intelligence cloud called Wildfire, right? So as Wildfire processes all these different files that we send to the cloud, if it detects a file that's malicious, automatically through dynamic analysis, we're going to create protection profile. So we're going to be reprogramming our firewall, the next generation firewall automatically based on what we're seeing in the cloud, right? So it can be that we can obviously create an antivirus signature for a bad piece of malware, a malicious piece of malware. So we can create a signature automatically for antivirus signature. We can also block the C2, the command and control automatically, right? So if we see a command and control that we haven't seen before, we can create an automated signature. And all this gets updated every 5 minutes on our firewalls, right? So automatically, right? And we can go pretty deep into that. If you have any more questions on that, again, you can come back to boot. The second pillar is API-based security, right? Because AWS exposes all these rich APIs, we can take advantage of those, right? So we'll look at it a bit more later, but basically we have a solution that's API-based security that looks at different best practices and how these instances are deployed and configured. And based on what we can pull from the API, we can create compliance reporting, and then we can automatically remediate as well. And then on the host, we always have to protect the host, right? So we also have a host-based prevention called Traps. And according to the latest NSS Lab result for advanced endpoint prevention, we finished top right for Traps as an endpoint, which we can use for Linux and Windows workloads in a public cloud and a private cloud, right? And we'll get into that a bit later. So for us, those three pillars, right? Inline security, API-based security, and then host security, really important to fully secure the cloud. So the first, VM series next generation firewall. So to protect inline segment cloud workloads. So obviously to protect from inbound and outbound attacks. And then we have a solution called Evident.io, which we'll get into that a bit more, but basically provides continuous security compliance checks all the time, continuously monitors the environment through API, right, to make sure that everything is configured as best practice. And to secure the host, Traps. And Traps is, we're not going to get too much into Traps, but basically Traps is an advanced endpoint prevention, endpoint detection endpoint. So basically it doesn't look for signatures, actually looks for behaviors. So we have an anti-exploitation, we have different anti-exploitation module that look for different types of exploitation, like to look like to historic event DEP in Windows as an example, right? So we look at ways that malware try to inject into memory to execute. And we also do static analysis as well that is trained from the WildFire threat intelligence cloud as well. So it's a multi-detection approach. It's not signature, it's signature-less. So basically using static analysis engine that's trained from WildFire, and also using anti-exploitation module that looks for specific behaviors that how attackers try to inject malware into a process and run it. Also, so we talked about the VM series, so prevent outbound and inbound attacks, and provide application visibility, and provide workload segmentation as well. So obviously, so we want to protect the work. Like I mentioned before, it's good to provide security between that web and the application, make sure that port is open from MySQL and only that port is open, but also we'll take it a step further and look at the actual application data. Right, so we have a signature that looks for this application. So we'll be able to see exactly or be able to prevent only a certain application to talk over, right? So now, obviously, because even if you open the port to only that port from MySQL data, that port can also be hijacked and used as a covert channel as a C2 as an example, right? So what we want is make sure that the traffic that goes through is actually MySQL traffic, right? It's nothing else than MySQL traffic. And we also can auto-scale based on triggers. We can auto-scale with ELB with AWS so that you can automatically scale up and scale down. And we can do this through firewalls can be automatically installed using CloudFormation template. We can also use bootstrapping, so we can use S3 bucket and then put all our files into an S3 bucket and automatically bootstrap our firewall so that as we need to, we can bring them up and down. And they can then connect automatically back to Panorama and connect to a device group and get their policies automatically. So firewalls can be basically part of a no-to-scaled design. And let's talk about continuous monitoring and compliance through API security. So we have a solution called Evident.io. And what Evident does is basically, again, leverages the AWS API set to gather as much information as it can from IaaS and PaaS services, right? So as an example, is MFA enabled? Any sensitive data exposed? What services are running? Like, do you have Telnet? Do you have SSH running, right? you should know about those, right? And be able to block those if you need to. Who has access to these resources, right? So basically, we can, after we gather all this information, right? It could be like, if your CloudTrail logs are publicly accessible, as an example. That's one of the checks that we do, right? So what we do is we gather all this information, and then we can create compliance reporting, right? So as an example, we provide a NIST 800-53 compliance report, right? It's a very extensive report from NIST or GDPR. I'm actually working on translating the NIST report that we have to ITSG 33. So we have a compliance reporting module that provides us the ability to create custom signatures so we can look at very specific things through the API. So I can look at for ITSG, to make ITSG 33 as an example. Today we don't have ITSG 33, but NIST 800-53 maps very closely to ITSG 33. So Evident.io allows us to gather all this information and create compliance reporting so you can automate that process of making sure that you're still in compliance within those deployments, right? And you're deploying it according to best practice all the time, right? And again, with Traps workload, so with Traps, also one thing to point out is a very, very lightweight workload. It's not something that's heavy on memory, heavy on CPU. It's not always scanning. It scans on demand when we need to. When we install a new file or run a new file, it will scan to make sure that the file doesn't load anything that's not supposed to in memory. But it provides real-time exploitation and malware protection, right? There was a lot of campaigns in the last couple of years that used vulnerabilities that were like, very recent vulnerabilities that Traps was blocking even with a version that was 3 years old. Why? Because we're looking at exploitation technique, very specific exploitation technique. And we have right now 32 modules loaded in Traps that look at very specific exploitation techniques that cover a bunch of vulnerabilities that were released in the last 10 years. A lot of our customers deploy Traps on, believe it or not, XP just because it can be patched, obviously, right? And sometimes they just can't remove XP from these environments, right? So they deploy Traps for that to protect unpatched workloads. So if we look at the whole platform here, so again, to finalize here, so basically we have our VM series firewall, we have Traps, Evident.io, so the three pillars here. And on the right, you can see where threat intelligence comes from for Palo Alto. So we have our Wildfire Threat Cloud that I talked before that collects a lot of information, a lot of files from all our customers, or 54,000 customers, and 32,000 of those customers provide us all these files that we can analyze these files, make sure they're malicious. We can create protection profiles, and those protection profiles can be an antivirus signature, an IPS signature sometimes, and it can be to create a DNS signature for a bad list of domains. It can be recategorizing a URL because that URL is using as a C2, so recategorize that as C2 as an example, or just a malicious if it's just a phishing link. And we also have obviously third-party, different type of third-party feeds. And then we also have something called a Cyber Threat Alliance that we have a Cyber Threat Alliance with a lot of our competitors, actually, Cisco, Checkpoint, Fortinet, and we share threat data across these organizations. We don't share signatures. We don't share how we create signatures, but we do share threat data, and we share basically zero-day malware that we've discovered, and we share that across this alliance. So once we have all this information, right, we create protection profiles for malware, for antivirus signatures, for threat prevention, for IPS signatures, and URL filtering, and this is all automated, right? Every 5 minutes, anything that we find that's new that we haven't seen before, we automate that and create signatures for that, and then that gets propagated across your different firewalls that are installed in the cloud or on-prem, right? So SaaS security approach. So also with SaaS security, so what we can do is as well as that we can leverage API as well, API security as well, so that we can tap into APIs to look into the content that are basically stored into these SaaS services, how the data is shared in those SaaS services, if there's any API data or secure or personal data or financial data as an example that's being shared in those SaaS services, so we can look into that information and see how it's being shared. It automatically remediate if there's data that's in there that's we deem to be sensitive. As an example, it could be financial data is being publicly shared as an example, right? So we can automatically scan for that information as well. And our approach for SaaS security is a solution called Aperture. And Aperture, again, is API-based security, so it allows us to connect to these environments. So what we look at is basically we have unsanctioned SaaS app, tolerated apps, and sanctioned apps. So the first line of defense is always our firewall, right, or for inline security, right? So our firewall is application aware, so it will actually give you a lot of information on the application, right? Be able to filter all these applications already. And also from there, we'll be able to reduce the attack surface by saying, okay, so certain of those apps will be unsanctioned, meaning that I'm going to block those, right? I'm not going to allow my users to use those at all, and I can do this from the firewall. Some of them will be tolerated, so I'll allow certain of those SaaS applications to be used or leveraged by my users, but I will limit them and then reduce maybe the file tab they can download, the different actions that they can do within those SaaS apps. And then there might be SaaS applications that are fully sanctioned. So fully sanctioned SaaS app meaning my users can use them to store files, to use them the way they want. But with an Aperture, I can use the API that are exposed to, like, say, a Dropbox, and be able to look into these applications and be able to report on any activity within those applications. As an example, again, scanning for file types that are sensitive and how they're being shared. And then also malware as well. So be able to scan using Wildfire as well in these environment and send content to Wildfire for scanning and make sure there's no malware in those environments. So basically, yeah. So basically, that's it, right? So we're trying to provide an approach that is consistent everywhere for IaaS, PaaS, and SaaS. We have tools to provide a consistent approach across your security for your data center on-prem and in the cloud, so that you can provide a unified prevention approach to your deployments. Thank you.